Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about the lists. So we have talked about these strings and how to do string processing, and we've seen how strings can behave like a data structure. Today, we're going to see another data structure that's called the list, which will allow us to have multiple items inside of a single container, which is called the list, which we'll see is held by the square brackets. And many of the things we can do with string processing, we can also do with the lists, but the lists also have the capabilities to do some more additional things, which I think you may find very helpful for your projects. So let's go ahead and get down to business. I'm going to share my screen, and as always, you are welcome to follow along with the slides or to get your own slides off of our webpage, whatever suits you best. So let's go ahead and see. So this will hurry up. Sorry, this did not. So just to get an overview, we're going to take a look at a number of things that we have talked about with the strings today, and then we will have an introduction to the lists. And coming up, we'll take a look at some familiar tasks that are overloaded for lists. We'll look at looping over lists, which works much the same as it works for strings. And then we will look at the topics of assignment, mutation, and some special built-in methods that are available for working with the lists. So let's just call to mind a few of the things about the strings. So remember in the strings that we could take the slicing and indexing of them. So for example, we could ask the question, what is Python going to return for these? And we remember that when we have this range here and nothing specified on the other side, that it's going to go from the position that's indicated all the way to the end. If you don't tell something in the beginning, it will start at the beginning. If you don't tell something at the end, it will go all the way to the end. And so here we could take this string and we can process it via these various slices to get out the secret messages. And when we do this, we see that S of 16 to the end gives us ida, S of 5 plus S of 2 to 5 gives us where, and then we can do this little message here, which is also featuring some repetition and some concatenation of the strings in order to give us clear water. So write a function that will process each character in a string. If it finds a space, it should replace it with an underscore, return that result. So how would we do something like that? It would be something perhaps like this. We'd start off with an empty accumulator and we'd do character in S, that is for character in the string. If the character is equal to that space, that means if it is, this is the Boolean equal, don't forget, then we would accumulate an underscore as opposed to accumulating the current character. But if we're going to proceed on without that, we would just do the accumulator plus equals that character, and then we could return that accumulator, and we could convert from a string that has spaces in it to one that has those spaces replaced by the underscore. So with those things in mind, let's go ahead and start looking at this other data structure, such as the list. So lists and strings bear many similarities, and I'm just outlining a few of them for you. They can be manipulated in many of the same ways that parallel how strings can be manipulated. They contain multiple elements, and their elements can be processed in loops, but they do differ in two important ways. The elements of a list do not all have to be of the same type. And the other thing is that lists are mutable. The contents can be changed after they're created, which is not true of the lists, of the strings. And you might say, well, yeah, I can just save the string again, which is true, but that's variable reassignment. You can't go in and change a piece of the string. Whereas with a list, you can go in and you can just change a single entry. And that's what's different about this. That's what is the property of mutability, being able to go in and to change just a piece of it while it's already on the disk. So let's just take a look at these two programs here. Here is a program that's going to calculate an average score. So this might be, for example, an average test score. So let's suppose you have these grades in some class, score 1, 2, 3, 4, and 5, and you want to know what's my average in the class. You could simply get your score total, and you would sum up all of these scores, and then you'd say that your score average is equal to your score total divided by the number of scores that you have, which is 5 here. And then you could print out the average, and this would calculate your average, right? This is something probably you know how to do. But there are some problems with this. And this gives us a sense of why we might want to work with the lists. So, well, what if there's another test? Okay, we won't be able to divide by 5 anymore. You're going to have to open this program up, and you're going to have to hard code in another score. So you'll need to code in score 6 and its value, and the score total will need to be divided by the actual number of scores that there are, and then you could print it out. But what if you could do it with a list? I know we haven't done the list yet, but let's just preview this. I think there's a lot of this you could understand already. Scores are equal to the same number of values that are over here, but notice that we don't need to write out a single variable for each one. We simply make one variable, and this holds all of the data all inside of one data structure. Then we could initialize our score total to be 0. This is called initialization. Now we can do some looping. For score in scores, the score total plus equals that augmented assignment score. So we will simply cycle over all of these scores, and we will total them up by adding them to this running total, which is score T. Then we will compute the score average as the score total divided by the length of the scores in here, which will automatically calculate how many are in there. It's not perfect because you still need to open it up, and you still need to put in the next test score if you get another one. But you see that it has some advantages. There's a lot of things you could do with this that are going to need to be done explicitly with this. So then you can print your averages and the average score. So hopefully you can see that this might have some advantages, and you might be thinking about your projects and thinking, you know, maybe this would be a helpful thing for what I'm trying to get done. So let's take a look at how we would actually make the lists. This is the syntax: enclose a list in the square brackets and separate the elements by a comma. An empty list is simply just the square brackets like this. The index of items in the list begins at 0, just like the indexing of strings also began at 0. So you would have your name of the list, which, by the way, is going to follow the same conventions as all the other Python naming conventions, equals, and then you would put your various elements in the list. So here is the list containing 3 integers. Why make all of them be floats or all strings? You could do whatever you like. So here's a list of 3 integers, and I'm typing those into Python, and Python tells me back, confirming what it is. Here is a list called A, so I can set a variable equal to the list. This happens to have 3 strings in it, which are of length 1. And we can ask Python what this is. Here's a list called B that contains 3 strings that all begin with the letter B. Here is a list called prices that contains 3 floats. So here we have some various floats, and that's in a list called prices. The idea of homogeneity is an important one in Python. A homogeneous list means that all elements of the list are of the same type, whereas inhomogeneous means that the elements of the list are of mixed type. Some are one type, another's another type. So it's possible to make an inhomogeneous list, but they are generally not a practical thing to do, especially if you're going to loop over them. So you really should be sticking to a homogeneous list unless you have a real reason not to do that. And the reason is because if you try and cycle over your list and you have an item in there that's of a different type, what's going to happen? Well, that's a good question. A lot of bad things could happen, and so that's a bad idea. So generally speaking, we don't want to mix our types. So here's an example of a homogeneous list. All of these are of type string. These are all of type integer. So this is homogeneous. These are all floats. This one has an expression in it that converts to a float. This is another expression that will become a float. and this one's already a float. However, you could have an inhomogeneous list. This is what it would look like and how you'd recognize it. You'd recognize it because the types are all different. We have a float, a string, and an integer. So that is an inhomogeneous list. So please refrain from using inhomogeneous lists unless there is a real reason to do so. So homogeneous lists as input function lists can be passed to functions just as an argument. So this is how you can pass it. You can pass one variable, but why not pass one list? Sure, no problem. This type of list is going to be list. So in the signature, the type of the element of the list should be specified parenthetically after list. So let's just take a look at an example. Here is process list of numbers. So let's say that we wish to have a function called add num, and it's going to take some variable called nums. Let's just take a look at what this is. So here we have list 1, 2, 3 has the integers of 1, 2, and 3, and we're calling our function with this list. So this list here is in the position where we're going to make the function call. So that means the whole list is what is going to be passed in. There'll be a local variable assignment of nums to the list 1, 2, 3 values, which will mean you'll pass that list in. So what we're going to do then for the signature is it is a type list, but we want to indicate in here what the types of them are. So I'm going to put floater in. These ones happen to be integers, but we could also use a float. That would be just fine. And this is going to return a float. It adds the numbers in the list as float. If it's empty, it's going to return 0. So we start off in an accumulator being equal to 0. And now we're going to cycle over the list for num in num. So it's going to cycle over this much the same as we would cycle over elements in any for loop. We've seen this with the strings. The accumulator is going to do a plus equal to add the element of float of number, and then we will return that accumulator. So we're going to cycle over the list. First, we will extract 1. So num will become the variable, we'll take on the value of 1 because that's the 0th item. And then the accumulator will do plus equal. And this is where it gets converted into a float because we have the conversion function right here. So it's going to do float of the number. And then we are going to go back up to the top and the number will then be equal to 2. And remember that the accumulator now is equal to 1. So the current value of the accumulator is going to add to it float of num, which is going to be 2. So we'll add 2 plus 1 back to the top. Num automatically moves over to 3. And now we're going to do the accumulator adding float of 3 to the current value of the accumulator, which is 3. So we get 6, and we'll return the accumulator and we get the 6 is a float. What will happen if you try to process a list of strings? So here, let's do add strings of string. And here we see we're going to similarly have a list. This is going to be list ABC with 3 strings in it. And we're going to add the strings by calling this function and sending up the list of ABCs. So here we're going to do list of type string. So I'm putting string inside my square brackets to indicate that it's list of strings. And we are going to get a string out. It's going to concatenate strings in a list. Remember that concatenation is what the plus is overloaded to do. We will start off our accumulator being equal to the empty string. Notice this is very similar to what we did over here, but what is equivalent to having nothing in the accumulator yet? Well, this was equal to 0. Here we have the empty string. So now we're going to do for string and strings, we're going to have the accumulator adding by concatenation the value of the string. So we'll begin with A back up to the top. And so now the string will collect the next one, right? So our pointer moves to B. So the accumulator will now have A plus B. And then we go back up to the top and we have the third one, which is going to be C. So we now collect the C in there and we return the accumulator and we will have accumulated back the string ABC. So that's how that works. An example of working with lists with the addition and with string concatenation. So why not have a list be an element of a list? What an idea. That's entirely possible. The element of a list can be a list. So if you have my list here, we're going to have the first element of the list be a list, and here's another list, and here's another list. And we recognize that we have the outer parentheses, And we have the inner parentheses. These are done as the square brackets. And the elements of the list in the inner list are separated by commas. And the outer list is comma separated as well by these commas between the square brackets. The 0th element of my list is a list. So if you do my list of 0 to do slicing, we'll pull out the 0th element of the list. And that happens to be this list here with ABC. Now, don't forget that we started 0, so 0, 1, 2. If we take the second element of my list, it could be selected with my list of 2, and we get X, Y, and Z, that list. The reason why this is so helpful is because you can use lists of lists as XY coordinate arrays. This is really helpful for any kind of game board where you're going to have an X and a Y coordinate to it, anything that's two-dimensional. So let's imagine that you're interested in the Battleship game board. This has an ABC and a 1, 2, 3 going across the side and top. And what I've done is I have numbered these over here in this board representation. So I'm running the ABCs. This is the representation that you see in the original picture. And now I'm running the numbering for Python on the other side, 0, 1, 2, because that's how Python indexes its items. And now we're going to have 1, 2, 3 going across the top, but Python will index them is 0, 1, 2, so it starts at a different index. So now we can just look on this little grid to see where things are at. And so we see that we have these 4 pegs, which I am labeling S, H, I, and P for convenience here, and we can see that this is where they would fall on our representation of this board. So here we can represent the game as a board. So here I'm going to have a variable called game, and it's going to be a list of lists. So the first list is going to be this row going across the top. The second one is this one that has the ship in it. And the third one is this one right down here. So suppose you want to pull out a particular row. Well, you do just issuing the index, game of 1, 0, 1. So we see that's the one that has the ship in it, and we can see the index labeled right here for our convenience. And it will pull out this list. And then we get a Python list that represents where the ship is at. Suppose you want to pick out a particular peg, perhaps one of these. Well, you can do that by issuing a double index. And it would look something like this. So game of 1 pulls out this ship, this row with ship in it, just like so. But then if you say that, and then you pass to it the 0th argument, then it says that it will go to the position 0 in the thing that it just got, which is the character S. And so we can proceed with game of 1 of 0, 1, 2, and 3, 0, 1, 2, and 3, to actually get out the various pegs. So basically what this does is it allows you to build an XY coordinate system using the rows and columns by issuing a row and a column position, an X and a Y coordinate effectively, so that you can now work on any game board. So if you want to use a game board in your projects, now you know how you can make a coordinate system to do that. We are also going to talk about some familiar tasks that are overloaded for working on lists. You've seen many of these in the strings already. So for indexing and slicing work pretty analogously to how they work in the strings. Indexing returns a value, whereas slicing returns a list. And this kind of makes sense because when we used to index something, we used to pull out a particular character in a string, but now the individual items making up the list is not a single character, but it's whatever item is there in the list. So it will return that value. And the slicing is going to pick out a range of pieces. So a range of pieces is best represented as another list. So when you do the index slicing, you'll do list, and then you'll use the square brackets and provide an index. So here is some cities. And if we do cities of 0, we'll pull out the 0th city, which is Tampa. And if we can also use the negative indices, just like we had in the string. So 0, -1, negative, yes, because it starts not at 0, -1, -2. So you pull out Orlando. So we can see this is the forward indexing, and I have also noticed the backward indexing for you as well. So the slicing syntax, here we have list of the start index colon and the stop index, just like we've done before. So you would go up to, but not including the stop index. So for example, cities of 0 to 2 is going to begin at the 0th item and go up to the 2th item, 0, 1, 2, but not included. So we go back to Orlando, and that's why we get this. 0 to 3 is the trivial case of selecting the whole thing. If you omit something in the beginning, it will assume you want to be a 2, so it's the same as cities of 0 to 2. If you want to use, okay, so this is -2 to 0. So -2 is here and 0 is here. So remember we talked about your selections need to go from the left to the right, but this one goes from the right to the left. So just like with strings, you're going to get the empty set because it's going backwards and it will just return that it's empty. Okay, but you could do -2 up to the end, which is fine. So you begin at -2 and you go to the end. So you'll pick up Orlando and Boca Raton in that case. There's also addition and repetition, the plus for concatenation and the star for repetition. They're operators that are overloaded for lists, so we can do concatenation of 2 lists. So here's an example of ABC and another list having D and E, and it will simply just join all the lists together in the order of which they were added. We can also do repetition, so you'd have list 1 times and some integer. So here we have 1, 2, 3 times 2, and what it's going to do is it's going to repeat the contents of that list and put them all into the same list. Here's another example of it, cat and dog times 2, so it will again make the contents repeated that many times and they will be in a single list. There's also the list coercion function. The list function can be used to generate a list out of a string. So you can do list of a string. So suppose you don't want to type each individual character of Fort Lauderdale. You can just do list and type it 1 time, much easier than typing all of those quotes, and it will explode it out so that each one is the item in a list. You can also do list comparison. So I've seen less than, greater than, less than or equal to, greater than or equal to, equals, equals, and not equal to on the strings. And these operators are all going to work on the lists as well. So here we're showing the inequalities examples. The Boolean will be returned based on the element pairwise comparison. So instead of comparing character at a time, it will do a comparison of the elements, and it will resort to pairwise comparison if the elements need to do a comparison. So for pairwise comparison, recall capital letters go before lowercase. So you could do, for example, 0, 0 is less than 0, 1. So it's going to do 0 compared to 0, no determination. 0 comes before 1, that is true, so we get a true. And again, we're going to do, again, element-wise comparison. 0 is greater than 0. No, 5 is greater than 7. That is false, so we can make a determination. Now we're going to do zoo, bark. It comes before aardvark and dog. So we do zoo comes before aardvark. So they're not the same. So now we need to resort to doing the single character comparison. So we do a Z, capital Z comes before lowercase a, and that is a true statement. So we can already make a determination here, and so we get true. Now we're gonna do lion and tiger comes after lion monkey, so we cannot make a determination on the lion comparison, so we go for tiger to monkey, so they're different. So now we're gonna do the individual character comparison. T comes after M, which is true, and so we get a true designation here. We can also use length. Length can be used in a similar way to how it's used in the strings. It will return the number of elements in the list. So if you simply just do length of list, you will get the number of items in the list. You simply just count them up as you normally would. We also have the in operator. The in can be used on lists similar to how it's used on strings. It returns a Boolean to indicate if the query is in the list. So you would do query in list. So for example, here's a list and you ask Miami in my list, and it's true, it's right here. Boston in my list, no, false. And clear in my list, oh, it's right here. But again, of course, you can't do that. It needs to be a complete match for the item in the list. So you will get a false. All right, well then, I hope that this was helpful in getting started with the list. A lot of these things hopefully are sounding a little bit familiar to you. And hopefully you're also gaining some new insights into why the lists can be so useful. Thanks so much for joining us. And we look forward to talking with you the next time. We'll see you later.